Okay, so we're looking at this graph. This is on Google's search page here if you just type that into the search results. Anyway, this is our function x squared over x squared minus 9. And so by taking a look at this function here, the graph of the function, we can kind of see a lot of what's going on. However, we're going to do the math and prove this stuff. But by looking at this, it looks like right in this area right here, we've got a maximum, a relative max, and doesn't look like we have any other minimums or maximums. You can see the y value over here. If you watch the dot, okay, it's decreasing and decreasing, 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 and so forth. Alright, well, let's get busy with the math. Alright, so writing this out, we have f of x, of course, is equal to x squared over x squared minus 9. So the first thing I want to do is take the derivative. So I'll write f prime of x is equal to, so we take the derivative of the numerator, and derivative of the numerator is 2x times the denominator minus the numerator times the derivative of the denominator, and derivative of x squared is 2x, and the derivative of 9 is 0. Alright, so we're done with that. And then of course, down here in the denominator we have to square that, so that becomes x squared minus 9 squared. Right? So now what we're going to do is we're going to clean this up. So f prime of x is equal to, now I'm going to distribute this 2x across, so we have 2x cubed minus 18x minus 2x cubed, and that's all over x squared minus 9, right, quantity squared. F prime of x is equal to, now as you can see we have a 2x cubed and a minus 2x cubed, so they're going to cancel out, and we're just going to be left with a negative 18x over x squared minus 9 quantity squared. Okay, finally we took the derivative. Oof. Now what we want to do is set it equal to 0 and find these solutions to this equation. And those solutions are known as the critical numbers, but we're also looking for numbers that make this undefined, like vertical asymptotes. Okay, those are known as critical numbers also. Just to clear that up, there is a critical number theorem, or is it a definition? I don't know, that I hadn't officially stated, but okay, so we take the numerator and we set it equal to 0. And of course, the solutions to this equation, better write CN again down here, right? Okay, so our critical number is 0, right? That's the solution to this equation here. And then what makes the denominator 0, right? This is where our vertical asymptote is taking place. So we set that also equal to 0. And we find the solutions to this. Now don't worry about that piece right there. We're just interested in this guy here, okay? Well, you know what? I better just go ahead and add it. People might get confused. But 3 is a critical number. When you plug 3 squared in, you get 9, and 9 minus 9 is 0, and 0 squared is 0. So 3 is one of them, and negative 3. Right, we plug negative 3 in, we square it, we get 9, 9 minus 9 is 0. Okay, so here's our critical numbers here. Alright, so now we're going to do our number line. And I'm going to plot 0, negative 3, and 3 on our number line. And then of course we got test points like negative 4, negative 1,